So this is really going to be about rational exponents or fractional exponents, if you may, or if I may. There's possibly something that I hope it was shared with you at some point in time in your high school math world, but just trying to make sure I'm covering everything by, yeah, okay. So that 4.3 is really having exponent of 0, which I addressed in an earlier video. And I guess I'll embed another one but that I made previously. But rational exponents or fractional exponents. In this book, they call it fractional, but rational, same thing. Because a rational number is a ratio of two integers. Like 3 and 7, so it's a ratio of two integers, which of course is a fraction. So whether you say fractional or rational makes a little difference to me. Okay, so can we have the number 2 to the 1/3 or 7 to the 3/5? And the direct answer is yes, of course. If we couldn't, I wouldn't be bringing this up so much, right? What I think happens is when we're in middle school, and hopefully in high school we get rid of it, but in middle school we still use it, of course, all the time. But in middle school we exclude some other information. For instance, if I want to take 16, let's say I have x squared equals 16, and let's say it's 7th grade and you're using the Pythagorean theorem for the first time, and you get this kind of thing. And so you want to solve for x, so you want this x squared to become x. And how do you do that? Hopefully everyone's like, yeah, I know, take the square root of both sides. Okay, so I'm going to take the square root of the left side, take the square root of the right side. And of course, the square root is an inverse function of squared. At least that's a way to think about it. A root function is an inverse function of a parabola. And therefore, when I do that, it becomes x, or x to the 1 if you prefer. And the square root of 16, in the form of an equation, the square root of 16, I have to consider both the positive and negative values that'll make the original equation true. And then the square root of 16 is 4. So in other words, if I put 4 in for x, I will get 16, because 4 squared, maybe I should do this for emphasis, 4 times 4 is 16. But in addition to that, if I take negative 4 and square it, I'm really saying this, which is also negative times negative is positive, and therefore I still get 16. So both of those answers work. When you're working with an equation and you take the square root of both sides, you need to consider, or the 4th root or the 6th root, or any even root, you need to consider the positive and negative possible solutions. But there's a more mathematical way to see what the square root is really doing, or what it is. So let's write this down again. Square root of x squared equals 16, and I want to solve, right, for x. So I need to get rid of that exponent. So let's do something instead of taking the square root of both sides. I want to raise that left-hand side to an exponent that when I execute this rule, a to the m to the n, which means a to the m times n, right? That's the shortcut from the other video, one of the few shortcuts. But I want m and n, when I multiply them, to equal 1. So I want m times n to equal 1. But I already know that this m is 2. So what do I multiply times 2 in order to make that, or turn it into, or however you want it, make this equation equal to 1, or that expression on the left equal to 1? Hopefully you're saying, well, I need to multiply that times 1/2, which means this n, this is going to be 1/2. So what I'm saying is I'm going to raise the left-hand side to the exponent of 1/2. If I do that, I must do the same thing on the right. Raise the right-hand side to an exponent of 1/2. And when I do this, when I execute this shortcut over here onto this expression on the left-hand side of my equation, I get x squared times 1/2, which of course is x to the 1, which of course is x. Over here, this 1/2 is the equivalent of taking the square root. and I end up getting plus or minus 4. Okay, so 16 to the 1/2 is the square root. So now, can you imagine if I had x cubed equals, what do I want? Let's just use 8 because that's just quicker, faster. So yes, in your previous life you would have taken the cube root, and you can still do that. That's not a problem. It's not wrong. What I'm trying to do is get you to be more comfortable with using exponents that are rational. So if I have the cube root of x cubed, of course, they quote undo each other. They're inverse functions, if you will. And I get x, but what's the cube root of 8? Well, cube root is asking what number do I have to multiply? Again, that language is kind of clunky. What number multiplied with that number 3 times is equal to 8? Well, I can also do this, right, and factor out that 8. And when I see 3 of them there, well, 2 times 2 is 4, times 2 again is 8, and so the cube root of 8 is 2. And no, you don't have to consider the positive negative, right? Let's review that quickly. If I put positive 2 and cube it, I get 2 times 2 times 2, which is 8. But if I take negative 2 and cube it, I get negative 2 times negative 2 times negative 2. These two give me positive 4. But then when I multiply that by the third negative 2, I get negative 8. So the negative one will not work. It's extraneous. It actually doesn't exist. You shouldn't be considering it when you take the cube root. It's only the even roots, because the negative gets masked or hidden when we have even exponents. Okay? So that's another way to work on this without using a root symbol and thinking of it maybe differently and or getting more comfortable with rational exponents, is that I could say I have x cubed and that's equal to 8, but I'm going to raise this side to the 1/3. Why? Because when I multiply these two, I will get x to the 1. Of course, that's x. And I will raise this side to the 1/3, which you should understand as, oh, that means 8, the cube root of 8. Or even better, whether you're using a graphing calculator or Desmos, whatever you choose, you can also enter it into a calculator, even your TI-84, etc., as 8 exponent, parentheses, don't forget the parentheses because you're making a fraction. In Desmos, you won't have to, but in your calculator, depending on whether you have the most up-to-date OS or not on your calculator, you may have to. So to be safe, just do parentheses, 1 divided by 3, and of course, like I said, we get 2, even though my parentheses are kind of not well written. There we go. So 8 to the 1/3 is 2, as I said. Okay? Now, you will possibly get problems in the future and or here in the homework session where I give you this. Let's see. Let's say maybe I don't want to do that. Oh, I guess it doesn't matter. Let's do this. Okay, so 27, and let's say to the 2/3, and I ask you basically to evaluate that. You could put it in your calculator, and of course, since we're online, that's the way it's going to be, and I'm not going to know any different, right? But if you really want to understand how to do this manually, I will give you this example, and I'll shut down the video. Okay, you can separate these two things in the reverse process of that. In other words, go backwards. Remember, this would have been, an intermediate step would have been x to the 3 times 1/3. So take this 2/3, rewrite this as 27 to this 2 times 1/3. Okay? Now, you could apply the 2 and square 27. That usually is cumbersome because the number gets larger. But again, if you're using a calculator, maybe it doesn't matter that much. You could change the order and do this. Because remember, multiplication is commutative. 2 times 3 is equal to 3 times 2, which is equal to 6, right? So multiplication is commutative, meaning I can multiply numbers in any order I desire and it won't change the outcome. So 1/3 times 2 is the same as 2 times 1/3, which in fact is 2/3. So now I can group this first power and separate these two exponents in this, again, this shortcut, I can take these two and write it like that. So I can write 27 to the 1/3 squared. But what's the cube root of 27? Put it in your calculator, or think about it if you want. You can do cube root of 27 is the cube root of 3 times 3 times 3. That's the factor of 27. And so, of course, that's equal to 3. So 3, and remember, we didn't get rid of this 2. That's still an exponent. All we did was figure out what 27 to the 1/3 is, which is 3. So we substitute this 3 in for this 27 1/3, because that's the parts that are being evaluated at this point. And then what's 3 squared? 9. So this number really is, although it's complicated when written as 27 to the 2/3, it's really just the number 9. Okay, so we'll leave it with that. If you have further questions, you can certainly shoot me a message.